Hello everyone, we have a problem here and we've been asked to find the area of the shaded region. At first it might be impossible to solve the problem, but it's easier than you think. The only thing that we know about this problem is this length, which is 10 units. At first we want to find the area of the shaded region, and we know that we should first calculate the area of a quarter of a big circle, which I donate the radius by big R. So I write 1 over 4 pi R squared minus the full area of a small circle, which I donate the radius by small r, and I write pi R squared. If I simplify it a bit, I can write pi times R squared over 4 minus R squared. So get back to what we have. If we write a line from the center of big circle to the circumference, we know that this line is R, and we also know that the radius of a small circle is a small r, which makes this length as 2r. So we have a right triangle because this line is parallel with this line, so makes this a right angle. So we can use Pythagorean theorem to find an equation between these parameters. So we can write r squared is equal to 10 squared plus 2 squared to the power of 2. So if we simplify it a bit, we get r squared is equal to 100 plus 4 times r squared. If we subtract both sides by 4 squared, we'll get r squared minus 4 r squared is equal to 100. And also if we divide both sides by 4, we'll get r squared by 4 over 4 minus r squared, which is equal to 25. If we take this, which we calculated here, to this slide, we can see that we get the same expression. So the area will be pi, and the expression inside parentheses we calculated is 25. So the area will be 25 pi. Thanks for watching.